Welcome back, each and every one of you. We, the first team of design thinking and problem solving, are back with our another video that is on blackout crisis in India. As far we have seen that this issue has much affected the country's people and its economy too on its own way. If this problem have not paid much attention towards it, this will create trouble for years and for years. So, being a technical student and responsible citizen of this country, this is our responsibility to take it very serious and to solve this very carefully. So, without wasting time, let's get into it. In this video, we will go through the introduction, Catwoe and solution. Introduction: a renewable energy future of India. A renewable energy is energy from sources that are naturally replenishing but flow limited. Renewable sources are virtually inexhaustible in duration but limited in the amount of energy that is available per unit time. Until the mid 1800s, wood was the source of nearly all of the nation's energy need for heating, cooking, and lighting. From the late 1800s until today, fossil fuels, coals, petroleum, and natural gas have been the major source of energy. The challenge before India is how to meet its energy requirement without compromising the ecology of the country. In India today, we face both an environmental crisis and a development crisis. On the one hand, we are still struggling with the problem of inequality and poverty. On the other hand, environmental pollution and ecological destruction. India is largely dependent on coal to meet its energy need. Coal meets more than 50% of the current commercial energy needs and generates more than 90% electricity. In fact, 3 exist a fatal overall of coal reserves, dense forest, tribal population, high poverty, and backwardness. Mining coal, therefore, leads to huge conflict between the local communities in one hand and destruction of the dense forest and wildlife, which may be extreme difficult or impossible to regenerate. The challenge before India is how to meet its energy requirement without compromising the ecology of the country. We cannot afford to let global temperature rise exceed 2 degrees centigrade from the pre-industrial era. India therefore must work with other countries to reduce greenhouse gas emissions and control the rising temperature. In such a situation, we ourselves cannot have a fossil fuel dominant energy future. So how do we move ahead? In last few years, 4 trends have become quite clear. The first is India's dependence on imported fossil fuels in increasing at an alarming rate. This trend has huge implications for energy security for the country. The second trend is reducing cost of renewable energy, especially solar and wind power. The third trend is use of electricity for practically all application. The fourth trend is the urgency of reducing greenhouse gas emissions.
We have arrived at the Catwoe analysis of our problem. So all of you are thinking why Catwoe is necessary. So let me tell you, Catwoe is a technique that provides a framework for defining and analyzing business stakeholder perspective, usually to get the heart of the matter and truly solve a problem once and for all. You need to look deeper at what is lying below the surface to reach a solution that is going to stand up for the long run. For this thing, we have to apply Catwoe technique to solve our problem. So let's see. First letter of Catwoe is C, which stands for customers or the consumers. So the beneficiaries of the blackout crisis are general public of India, industries, power generation plants, transportation and communication departments like railways, and state and central government. And the second letter of the Catwoe is A, which is termed as actors. Actors are the concerned board or people. Let's take a look. The main questions that arises are: the first, who is involved in this crisis to happen? The answer is the members of the Electricity Board of India, the insecure citizens, and the corrupt politicians. The second question is, who is part of these solutions? The answer is the responsible citizens of India, the youth, and the Electricity Board. And the third and the last question is, how will this solution affect them? Shareholders and the upcoming generations of India will have a great future by solving this problem. So let's come forward, and the third letter is T, that is transformation. As we have analyzed the scenario, we are forward to presenting you with some very beneficial and factful solutions. But before that, there are some general and common solutions we can implement to uproot the cause, like we can use renewable sources over non-renewable sources like solar energy, tidal energy, wind energy to generate electricity to some extent so that it fills the deficit electricity amount which it needs to run our country. So the next letter is W, which is abbreviated as worldview, or it is also known as Weltanschauung. After our problem gets solved, it means the solution will lead to our country's GDP to a great height and can improve our rankings in world's electricity generation and consumption list, and will be a great initial movement by our country to moving from developing to a developed country. And the next letter is O, which is abbreviated as owners. The owners are usually the central government to pass that bill, CEO and heads of the state and central electricity board to implement it, and the head of private sector electricity. And the next letter is O, which is abbreviated as owners. The owners are usually the central government to pass that bill, CEO and heads of the state and central electricity board to implement it, and the head of private sector electricity generation company. The last letter is E, which is environmental constraint, which is the biggest hindrance for our problem to get it solved. So let's see. The elements may halt operating the system are the opposition's politicians to the ruling party can halt passing the bill in parliament. Second, the external pressure from the electricity board. Third, some laws in our constitution may halt passing the bill. For the private sector companies. And the last, fraud and the corrupt politicians or employees of the electricity board and committee. So by analyzing all this, we can get a way to find a solution for our problem. So let's move ahead to the solution section of our video. So guys, we have approached to the solution section of our video. By analyzing the Catwoe, we have presented some solution. So let's see the solution number 1, that is tidal energy. So let's see, tidal energy is a form of hydropower that converts energy obtained from tides into useful forms of energy, such as electricity. Types of tidal plants are available in India are the tidal barrage. Tidal barrage are typically dams built across an estuary of bay. This part we are not gonna discuss today as it has many drawbacks to our environment. So our main focus is towards the second type, which is tidal stream generator. A tidal stream generator, often referred to as a tidal energy converter, is a machine that extracts energy from moving masses of water in particular tides. Although the term is often used in reference to machines designed to extract energy from run-off river or waves or tidal estuarine sites. Tidal stream generators have the advantage of being much cheaper to build and do not have as much of an environmental impact as a tidal barrage. The turbine turns relatively slow, hence do not affect sea life. This is different to tidal barrages, which can disrupt fish migrating up rivers from the sea. It has the capacity to deliver about 10 milliwatt hour per tide, which is equivalent to 6000 milliwatt hour per year, which is a good amount of electricity and has a potential to solve the problem. As India is a peninsular country, utilization of tidal stream energy is a good approach to solve the issue of power shortages and increase the capacity of power generation of coastal states like Gujarat, Tamil Nadu, Odisha, West Bengal and Andhra Pradesh, etc. The Ministry of New and Renewable Energy made a preliminary assessment of the potential of tidal energy in the country, and the assessment found that the indicated potential was estimated at around 8000 megawatt, that is 7000 megawatt in the Gulf of Khambat and 1200 megawatt in the Gulf of Kutch in Gujarat and around 100 megawatt in Sundarbans Delta in West Bengal. So the government of Gujarat is all set to develop India's first tidal energy plant. The state government has approved 25 crore for setting up the 50 megawatt plant at the Gulf of Kutch. We need more such type of generation plant to increase the generation capacity of electricity and to decrease the shortages problem in India. So guys, let's move to the next solution, which is solution number 2, It is about the usage of nuclear energy to produce electricity, as nuclear plants use fission to split atomic nuclei and release the energy that binds protons and neutrons together. It is the most complex process ever invented to boil water, which powers steam turbines that generate electricity. India's three-stage nuclear power program was formulated by Dr. Homi Bhabha, the well-known physicist, in the 1950s to secure country's long-term energy independence. For nuclear energy generation started there. Nuclear energy is the fifth largest source of electricity in India. As of November 2020, India has 22 nuclear reactors in operation in 7 nuclear power plants with a total installed capacity of 7,380 megawatts. Nuclear power produced a total of 43 terawatt-hour in 2020 to 2021, contributing 3.11% of total power generation in India, that is 1,382 terawatt-hour. India's nuclear power could provide a reliable solution to India's power demand as against wind and solar that is not available round the clock. This could further lead to a reduction in India's contribution to global greenhouse gases, which stood at 6.55%, with energy sector contributing a little over two-thirds towards it. India's current nuclear power capacity of 6,790 megawatts is expected to increase to 22,480 megawatt by 2031. This in turn is going to assist the country in meeting zero energy targets along with other clean energy sources, which is a huge amount, and continuous and controlled nuclear power can lead us to enter an era of India where there is no shortage of electricity. Let me explain you the working principle of nuclear fission plants of how they generating electricity through it. Nuclear power plants are a type of power plants that use the process of nuclear fission in order to generate electricity. They do this by using nuclear reactors in combination with the Rankine cycle, where the heat generated by the reactor converts water into steam, which spins a turbine and a generator. Nuclear reactor is a key component of a power plant as it contains the fuel and its nuclear chain reaction. Along with all the nuclear waste products, the reactor is the heat source for the power plant, just like the boiler is for a coal plant. Uranium is the dominant nuclear fuel used in nuclear reactors, and its fission reactions are what produce the heat within a reactor. This heat is then transferred to a reactor's coolant, which provides heat to other parts of the nuclear power plant. In nuclear reactor, control rods are used in nuclear reactors to control the rate of fission of the nuclear fuel. Uranium. Their composition include chemical elements such as boron, cadmium, silver, hafnium or indium that are capable of absorbing many neutrons without themselves fissioning. The production of steam is common among all nuclear power plants, but the way this is done varies immensely. The most common power plants in the world use pressurized water reactors, which use two loops of circling water to produce steam. The first loop carries extremely hot liquid water to a heat exchanger where water at a low pressure is circulated. It then heats up and boils to steam and can then be sent to a turbine section. Once steam has been produced, it travels at high pressures and speeds through one or more turbines. These get up to extremely high speed, causing the steam to lose energy. Therefore, the condensing back to a cooler liquid water. The rotation of the turbines is used to spin an electric generator which produces electricity that is sent out to the electrical grid.
Let's move to our next solution. Generating electricity from raindrops efficiently has gone one step further. A research team led by scientists from the City University of Hong Kong has recently developed a droplet-based electricity generator, which is also known as TEG, featured with a field effect transistor, which is also known as FET, like a structure that allows for high energy conversion efficiency and instantaneous power density increased by 1000 times compared to its counterparts without FET-like structure. This would help to advance scientific research of water energy generation and tackle the energy crisis. So now, let's move to our next solution. The footstep arrangement is used to generate the electric power. Nowadays, power demand is increased, so the footstep arrangement is used to generate the electric power in order to compensate the electric power demand. In this arrangement, the mechanical energy is converted into electrical energy. The upper plate is mounted on two springs. The weight impact is converted into electrical power with proper control unit. The spring and rack and pinion arrangement is fixed below the footstep, which is mounted on base. Now let's discuss its functioning, how it works. For one step of 20 kgs of load applied on the footstep, the generated voltage is 2.6 volt and the average current produced is 12 milliamperes. Hence, power is equals to 2.6. Power generated per hour is 0.0312, which is equal to 112.3 watts. Thus, the obtained power for continuous load applied on the footstep for 1 hour is 112.3 watts. Now, let's discuss the components which is used in this. First, 1 springs, 2 footsteps, 3 gear wheel arrangement, 4th, rack and pinion section, 5th, DC generator, 6 LEDs, 7th, shaft, and the last is battery.
Now let's start the solution 5 of our project, which is fuel cells. Let's discuss the pros and cons of fuel cells. Let's start with the cons of the fuel cell.
Generally having a higher upfront cost than CHP and solar plus storage systems because of higher availability and resiliency value, upfront cost can be significant for customers unable or unwilling to take advantage of a variety of available financing options. Businesses or communities that do not value resilient, always on power can expect longer payback periods on such investments. Now let's talk about the pros of the fuel cells. Convert fuel into electricity through an electrochemical process rather than combustion, avoids emitting harmful criteria air pollutants that causes severe respiratory diseases and poor air quality worldwide, cleaner than conventional combustion based technology, extremely high efficiency, use less fuel than the conventional grid to create the same amount of electricity, offer fuel flexibility, can run on natural gas and reduce carbon dioxide emissions compared to the grid and other combustion technologies, can run on biogas and hydrogen. Easily integrated into communities or corporate environments due to compact physical footprints, extremely space efficient with a high power density and minimal noise profile, rely on redundant, secure underground natural gas pipeline infrastructure for fuel supply, provide power both when the grid is available and when it is down in perpetuity, offers highest level of reliability for critical facilities that rely on an uninterruptible power supply, modular by design. So there are multiple independent power generation modules available. Maintenance doesn't require a full system shutdown like CHP systems. Do reduction in utility costs are typical much higher than other systems because of the modular design that enables 24/7 power generation with high availability.
Solution number 6. State-run Coal India Limited, the world's top producer of the fuel, is seeking to increase daily coal supply to 1.9 million tons by mid-October from about 1.7 million tons currently, an increase that would go a long way to help ease the deficit. Deliveries to the power plant are currently short by between 60,000 and 80,000 tonnes a day. Government ministries and industries are working to closely monitor stocks and could move again to divert supplies away from industrial users like aluminium and cement maker to prioritize power generation. Rationing domestic power supply, especially in rural and semi-urban areas, may emerge as one of India's easiest solutions. There could be a larger role for natural gas to play even with global price currently surging. India has almost 25 gigawatts of gas-based generation capacity, though nearly 80% of that capacity remains unused because of high prices of the fuel. However, in a desperate situation, the gas-powered fleet could help prevent any widespread power outage. Some commercial establishments, including hospitals and malls, as well as small industries, use diesel-based generator to ensure uninterrupted power supplies in case of outage. Natural gas power plants generate electricity by burning natural gas as their fuel. Natural gas is added along with the stream of air, which combust and expand through this turbine, causing a generator to spin a magnet, making electricity. There is a waste heat that comes from this process because of the second law of thermodynamics. There are approx 50 natural gas power plants in India. The electricity generated by natural gas plants are 24,900 megawatt, which contributes 6.3% share total in India.
So guys, we have moved to the last solution, which deals with the power theft. Power theft is one of the major issues of electricity transmission and distribution. It is prominent in developing countries and results to an annual losses of around rupees 3,000 crores in India. It is estimated that power theft accounts to 1.5% of GDP, which is significant and can't be neglected. Power theft prevention is a system used to perceive and prevent illegal load tappings on distribution lines. Energy meter tapping can be detected by using a simple arrangement of an IR LED and a photodiode. It is used in cases where conventional electromechanical energy meters are used. Energy meter tampering detection and prevention can be done by a photodiode is placed on the shaft of the rotating disc on the meter and is illuminated with IR light from the IR LED. In normal operation, the output of the photodiode gives a logic low signal to the microcontroller. However, when the meter tampers, the disc rotation is obstructed or the meter cover is removed. An obstacle is created between the LED and the photodiode, resulting in a logic high signal to the microcontroller. The microcontroller detects the change in logic signal and based on this sends a message to the GSM modem through the level shifter MAX 232. The GSM modem then sends the message about energy meter being tampered at the particular location to the power distribution grid and appropriate action is taken accordingly. By this improvement in our meter lines, we can reduce the cases of power theft.
With this, we come to the end of our presentation. Thank you for being with us throughout the video. We're going to upload another video on this topic discussing the practical ways of solving power outage. So please stay tuned and like, share our video and subscribe to our channel.